Yeah, now that I put the chip in there with 5 bent up pins, I was looking again at this diagram, and the original memory that would have been perfect for this socket on the PCB had a non-connected on pin 19, so this pin was not being used, and I need address line 10. That's why I bent address line 10 up in here, but then non-connected. And then I looked at the board, and over here you see there are two links, LK1 and LK2. I think one of them is the power line, but the other, according to the schematics, one is for 1 kilobyte of RAM, and link 2 is for 2 kilobyte of RAM. And then if you look here, one is 5 volts, and the other one is address line 10. So if I just close one of these links, I have to check which one exactly, I can put this pin back into the socket. I don't need to bend this one up. I should have checked that before I bent the pins up. Anyway, let's do it now. Okay, according to the schematic, I have to close link 2 to route address line 10 to pin 19, in this case pin 21 because it's a larger chip. So address line 10 on the CPU is here, pin 40. So this here should be address line 10. And it is. Now, from this point here, because I will link from here to here, so this point here should go to my pin 21. And it does. So from here to here, I just feed address line 10 directly to that pin, which was non-used for the memory that Sinclair would have put in this socket. So now we should have a direct connection between address line 10 of the CPU, which is this pin, and this pin of the memory. There we go. Yeah, problem solved. Better than a bodge wire here to the board. So now we have only 4, not 5. This is also probably not the best I could do, because you know the order of the address lines doesn't matter much in a RAM chip. So that probably is a more economical way. Maybe I could save another pin, but yeah, I just want to do it in a self-documented way, meaning that anybody in the future who opens this computer and looks at this, they will know what the intention was of doing this. Okay, now we have to find the pads where to connect these lifted pins here too. I want to connect them to the CPU side of the address bus. So this part of the address bus here, not through this resistor bank here, but before. So the new memory is this chip, and I need to connect extra address lines from the CPU. So the right thing to do is to test continuity from the CPU to some of these pads here and here until I find what I need. So the first thing I need, well, I need address lines 10, 11, 12, 13, and 14. So address line 10 is on this side of the CPU. Oh, these I already have. I just connected it. Which one was it? This. Of course, the multimeter is off. So 10 I already did with that link. Yeah, so 10 is done. Now we need 11, which is on this side of the CPU. And it should be here somewhere. I hope. Because it's certainly coming. It could be on the other side of the edge connector. Oh, this goes to the keyboard, right? Yeah, these are the little diodes in here. So the address from the CPU wraps around here and connects to these diodes, so the CPU can also scan the keyboard. So I can plug address line 11. Yeah, but then I have to, I would prefer an empty pad where something not used right now. But apparently, yeah, this is so this is 11. So 12 should be here. Yeah, this is 12. 11, 12, 13. And 14, yeah. Yeah, we have everything here on these diodes here. Oh, I was really hoping one of these empty pads here would do the job, because I could then just heat them up and just stick the wire in there. Now I have to do it on a pad already used by a diode. Yeah, bummer. Yeah, it is done. I was hoping I could have used some of these unused pads here for the address lines I needed. I think in the earlier versions of the ZX-81 board, this was possible, but now I had to reuse the pads for the diodes in here. I can show you on a microscope how it looks like. Let me check for continuity, just to make sure before I do more work that everything is connected in the right place. So I'll start from A11 because it's easy. A11 on the CPU is here, and on the memory it is pin 23, which is, yeah, now I can't access it. I can still access it if I gently pull out the shrink wrap. That should be enough. So A11 on the CPU and A11 on the memory. Yeah, that's a good connection. Now A12 on the CPU and A12 in the memory. Yeah, connected. A13 on the CPU and A13 in the memory. It's fine. And finally A14 on the CPU and A14 on the memory. Yeah, all the connections are fine. What you see me do now is to protect the board with heat-resistant Kapton tape, leaving only the little pins of the memory where I put shrink wrap exposed, because I'm going to blow hot air on them to shrink the shrink wrap, and I don't want the other chips to be exposed to high temperature. Okay, here it is. The mod is done. Those are the extra address lines that could not be routed through the socket. So I just put some bodge wires and routed them to the nearest place where the respective address lines are present in the board. I've shrunk the shrink wrap here. The chips still got pretty warm despite the protective tape I put on top. So let's turn it on. Without the keyboard connected, I cannot check if all the 16 kilobytes are being addressed, because I need to type a peek command to see that. But since the video is mapped onto this same memory, if the computer turns on and shows me a prompt, it means that the ULA is able to access this memory, so is the CPU. So at least I didn't make anything worse. So let's see. 3, 2, 1. And we got the prompt, so everything is working fine. It took a little bit longer for the cursor to appear, which is a good sign. It probably is seeing all the 16 kilobytes addressable now, but we will confirm that later. Before putting it back in the case, I just want to do some final things. I want to clean up the edge connector here, both sides, while I have a chance. I want to clean these connectors here for the ribbon of the keyboard with contact cleaner, and very important, I want to put a very good heatsink on top of the ULA to protect it, because the #1 cause of death of these old chips is heat. I already swapped the linear voltage regulator with its heatsink, swapped it for a buck converter, which doesn't produce nearly as much heat. So the case will be cooler, and with an extra heatsink, I think the ULA will be protected. So here's our board. I declare it officially complete. I've left it running now for some 15 minutes, doing nothing, just on. I see the cursor on the screen, and it's remarkable how these CMOS chips, the Zilog Z8 is now a CMOS chip, a modern one. It's a modern SRAM here, also CMOS, and they hardly get warm. And with the heatsink, the ULA is also a lot cooler. Let's see the CPU first. CPU is running at 31 degrees. The memory 29.8, so 30. The ROM 30 point something. Let's check the RAM again. 30 point something. CPU 30.3. And now let's check the ULA. Yeah, it's a little higher, 35, but it was running at 55 before that heatsink. The only thing I wanted to do, and I didn't manage to, I wanted to check what type of ROM this is. It's a Motorola part. Some ROMs are what we call mask programmable ROMs, which means that the instructions in it, the information it retains, is etched into the chip itself in metal. So the ROM never loses its contents because, yeah, it's just etched in metal inside and the metal layers. But there are some ROMs which are electrically programmable. Even if only one time, they are programmed by flowing electricity through the ROM and burning some fuses inside. And those one-time programmable ROMs, or even there are some EEPROMs, as they call it, electrically erasable programmable ROMs. This one is certainly not one of those types, but it could be an electrically programmable ROM. And yeah, those may lose their contents over time. They were not made to retain their programming for decades, and this thing is end of 82. So yeah, it's clearly working. The chip is fetching the BIOS instructions and it's doing what it's supposed to do. So I will just assume that this is a mask programmable ROM that will last many, many decades. The case needs to be washed and refurbished, specifically, or more particularly, this. This is an original keyboard membrane, and it's probably not working. I couldn't test it because the rest of the computer was not working, but I have a new membrane which I plan to replace this one with anyway, because these things are, you know, almost 40 years old now. So I'm not going to trust them anymore. Anyway, so this is just glued on the case. So there isn't really a non-destructive way to do this. You just have to pull it out. I'll try to be as non-destructive as possible. Yeah, there we go. Here we go. This was really cheap. You can see the two sides of the circuit. Some lines go in here and traverse it horizontally, and the other lines come from here and traverse it vertically. And when you press a key, you close a circuit between one of these lines and one of these, and that's what the computer picks up by scanning here and here. Once it finds one of these, forming a circuit with one of these, that's your key press. Just have to remove the glue from here before I wash it further. I'll try first with just IPA. If it doesn't work, I will move to some WD-40. Works very, very well. There is no glue anymore. Okay, so these are ready to wash. I'll just remove the last little rubber feet. I'll probably need to replace them anyway. So let's go and wash them. Here you see my girlfriend doing some restoration work on the ZX-81 logo, which sort of faded out after I washed the case. She's an artist, she's a painter, and while the Byte attic is all the way up in our house, her atelier is all the way down. So I came all the way down and asked her for some help, and then she did a brilliant job restoring that little red logo. yes, that's my retro arcade. She's applying some boat lacquer to the logo to make sure that it will never fade out again. The case has now to dry in a protected environment so dust doesn't fall on it and gets glued to the lacquer. And the big moment is upon us. Here is the fully restored and upgraded ZX and the beautifully restored case. Thanks to my girlfriend for that. It has a new keyboard here, and yeah, the logo has been cleaned, repainted. There is also acrylic binding to keep the painting in place, and there is also boat lacquer on top, so this never washes off again. Funny thing is, I don't quite remember how to put it back together. It's not this way. I remember that the board was upside down. It's been a while. I bought the board and I had the case, so I think I'm going to first, let's see, yeah, this will go like this, so I have to connect the ribbon connectors first. Okay, before I put the rubber feet back or renew them and beautify it from the outside, I just want to do a quick test. I can't wait to see if it will recognize the 16 kilobytes of memory. Here is the refurbished, renewed ZX. Not only refurbished, it has been brought back to life. It didn't have a ULA, and it's looking the part from the outside. Let's turn it on. Takes a little while for the cursor to pop. By the way, that's Floki, one of my cats. He's most interested in the byte attic. Okay, I've typed this little command, which will allow us to see how much of the RAM is recognized. The first 16 kilobytes in the address space are the ROM. So if we get a little bit over 32,000 as return for this function, then we are in game. Let's see. Ah, the nostalgia of typing programs by hand on the ZX. This was magical back then. It still feels magical, almost 40 years on, and still feels magical typing these little basic programs. This one will fill the screen with some random characters, the graphics characters of the ZX Spectrum. Sorry, of the ZX-81. So if we type run and then enter, and it starts off. Black and white and no sound. If this is working like this, this ZX is fully operational. I'm going to finish up with some plastic cleaner just to give it a shine, just because I can.